Mentioned to you earlier, this is a fun vacation week for a lot of people. I'm taking vacation tomorrow myself. So many have asked that we record this session, and I do want to let you know that it will be recorded. So again, good morning and welcome to HP Aruba's virtual security showcase. And this is our part one. Our must-see session highlights our Aruba 10K and AMD Pensando chipset. This is our very first top-of-rack switch that acts as a stateful firewall, managing east and west traffic specific to its workload. It's like the bouncer within your network, and it's very sophisticated with programmable DPUs, providing macro and micro segmentation as well as encryption to protect your application and data inside your LAN. So without further ado, Steven Tanti, AMD Pensando Systems Engineer, is going to demonstrate how this new security design will provide 10 times the performance, 100 times the scalability, and for 1/3 of the cost when compared to other data center switches. But before we let him get started, I just want to mention a few things. We do have a question and answer section, section, of course, and for those of you that are unable to access that, we also have a chat section. I will be monitoring, and I want this to be interactive. So as you have questions, I will make sure to interject at the appropriate time so that Stephen can answer those questions for you. We hope that we entice you to set up a meeting with us. And without further ado, Stephen, you can take us away.
Awesome. Thanks, Brianna. Hi, everyone. My name is Steven Tanti. I'm a CSE for AMD Pensando. My partner in crime is Mr. Scott Chung, who's also on the call. Together, Scott and I cover really the whole West Coast, Denver West, for everything AMD Pensando. And, we spend pretty much all our time with Aruba and their customers, educating them and building new architectures around the solution, the CX10,000, which we'll talk about today. I'll go at a steady pace and try to give time for questions. So if there's any questions, as Brianna said, please don't hesitate to ask in the Q&A section. And also, I'm based in the Bay Area too. So if and Scott and I travel all over, so happy to meet with you all either virtually or in person if this is something of interest for you all. So first, you might be wondering, why is AMD in here talking about an Aruba solution? Well, Scott and I are part of a group within AMD called Pensando. AMD actually acquired us last summer. Our core product is a data processing unit. So just think of a data processing unit, or DPU for short, as a specialized processor for all things networking and packet related. So we're doing for networking what GPUs did for graphics, offloading that off general purpose compute and putting it on the more specialized silicon. So our DPU is offloading, accelerating things like software-defined networking, security, firewalling, software-defined storage, telemetry, encryption, etc. And we're in our second generation of DPU. And our DPU is unique, and you'll see how this comes into play later. We call our architecture software and silicon because we have a fully programmable control plane, data plane, and management plane, which allows us to really innovate and bring new features to bear with software while still taking advantage of hardware level performance. Now, we've built our portfolio over the last several years in several key areas. First, you'll notice on the bottom, the biggest part of our beta's business and where we started was deploying our DPU in several of the cloud hyperscalers. So we're in production in IBM Cloud, Oracle's OCI, and Microsoft Azure. And they're leveraging our DPU in several form factors, whether it's a DPU in a NIC, you might have heard the term smart NIC before, being deployed on the server side, as well as DPUs being deployed in appliances and solving, many different use cases across the board. Anything from helping them ramp up to millions of connections per second for their application connections, to building a full software stack of security, storage, and telemetry on the perimeter of their cloud. We also have the ecosystem part of our business, where we're partnering with different OEMs as well as software manufacturers. So for example, we have a full partnership with VMware, and we're helping them with their Project Monterey and their what they call the Virtual Distributed Services Engine. You might have seen that as part of vSphere 8. And we'll talk a little bit more about our ecosystem on the software side with some key players such as Guardicore, Splunk, Elastic, and Octera. And then last, but certainly not least, is the network fabric side of our business, where we're leveraging our DPU inside of a data center switch. And we have an exclusive agreement with HP Aruba to put our DPU inside of a top rack data center switch called the CX10,000. And, Aruba is way ahead of the game here. As you'll see, this is where we think the industry is going, putting this specialized silicon in networking, especially in the data center. And because of the exclusive agreement, Aruba is really kind of, at least 1 to 2 years ahead of the competition in this space. Now, if you look at the big picture, data centers have evolved, especially on the networking side of things, and they evolve somewhere in the range of every 10 years or so. And these kind of major architectural shifts happen, trying to solve a set of problems. For example, when we first started building data centers, they're very much layer 2 based, spanning tree based type data centers, because we had to build them that way, right? There was all these different protocols flying around, AppleTalk, DECnet, etc. And so we had to build them, based on lowest common denominator. But if you've been in the industry long enough, you know that these really big flat networks did not come without their share of headaches and pain points, especially around the instability in large broadcast domains that Spanning Tree brought to the table. And so when we got a more advanced silicon that can do routing and switching on the same platform, that's what led us to that second generation. We landed on IP as the dominant protocol. We started to build these layer 3 based 2 and 3 tier architectures. And I would say the second gen was where, life was pretty simple. Life was good. Most of the traffic was what we call north-south, coming in and out of the data center. So it was very easy to protect on the perimeter, because when a request would come into your data center, it would get processed on a big, large server most of the time, and that response to that request would come out of that same exact server. So very easy to protect, simple architecture. I think life was pretty good. But things like VMware came around and virtual machines, and even more so today with container microservices-based architectures. What happened was applications and workloads became more and more disaggregated or distributed within the environment, meaning now that same request that comes into your data center triggers a whole, slew of east-west communication within the data center itself. So, app to DB, front end to app, et cetera, type communication. I like to think of it as like a packet pinball machine going throughout the data center. And this explosion of east-west traffic led us kind of to, data center and network architects figuring out, how do I keep up with the real-time nature of these applications and workloads? And that's kind of where we've been in the last 10 years or so, architecting our networks in different ways, whether it's spine leaf, VXLAN, software-defined networking, trying to keep up with that east-west real-time nature of our applications and workloads. The challenge, though, is that connectivity is only half the battle, right? There's all these other infrastructure services that these applications and workloads need to run at scale, like security, firewalling, telemetry, encryption, load balancing. And today, those are all different appliances, physical or virtual, within the environment. And so, these stateful services are what we call bolted on, right? We've got to figure out, how do we architect or trombone traffic to these appliances just to insert that service between our workloads. And we're kind of at this peak complexity. It's really difficult to scale, really difficult to manage, many different operating systems. And really, I think this is we've been stuck in the last 10 years or so in this peak complexity. And frankly, a lot of people have sort of stayed in the second generation wheel because of that complexity. But there's all these other challenges with security as a big one of them that we're not able to solve for. And so where we see the industry going is, because of this new silicon, this new DPU architectures, by putting them into the data center switches, we're kind of creating a new category of switch, call it a distributed services switch, call it a smart switch. And really, this allows us to co-locate network services and have them be delivered inline per port at scale. And really, that's what we've done here with Aruba with the CX10,000. So what is it? The Aruba CX10,000, it's, first and foremost, a data center switch, right? So it's everything you expect from a data center switch, from, full network functionality, standards-based networking, OSPF, VXLAN, BGP, you name it. You can log into this switch just like any other switch. If you're familiar with Aruba, they're running that same, modern network operating system in AOS CX. We have one form factor today, and it's 48 25 gig fiber ports, 600 gig uplinks. But what makes this switch special is it is a multi-ASIC design. So because of those Pensando DPUs within the box, there's a pair of them, we're able to run 800 gigabits of wire rate stateful services right on the top of rack, right on the switch. And when we launched, we started with several features around, running a stateful firewall, DDoS, and telemetry. And we've since been upgrading our platform over the last, 12 to 18 months. We've added use cases around network address translation, IPsec encryption, and more services to come. And really building and collapsing all these services and have them be delivered directly by the network. Now, since the nature of this call is focused around security, and it is our biggest use case, I'm going to jump a little bit deeper into the firewall use case and the telemetry use case, which I think are the two kind of most important ones that we're solving for that IT teams and businesses can take advantage of. Brianna, any questions so far in the chat? I don't see any, I don't think.
No, I don't have any questions for you right now. Thank you.
Awesome. All right. So when we're talking about firewall and really services in general, there's kind of two main architectures that existed before, the CX10,000. The first one, which is maybe the most common one that customers are familiar with, is what we call a centralized security architecture, right? This is your traditional scale-up approach with a physical, next-gen firewall, or maybe even a virtual firewall to handle that east-west traffic, right? We're talking about that traffic within the data center, east-west, that workload-to-workload type communication. Now, to do it in this architecture, you have to really, first of all, figure out how do I get that traffic to that appliance, right? If there's a workload in rack A that wants to talk to a workload in rack B, and you want to insert stateful security between that communication, you've got to trombone that traffic across the data center to that appliance and back, right? So these red lines sort of depict traffic going to and from and back, right? So you very quickly see it's taking a very inefficient path to get that service inserted within this communication path, right? So you're wasting pretty much double the bandwidth across your core or your spine because traffic is bouncing back and forth. You're introducing extra latency because now you're traversing extra switches and that centralized appliance inserted in the path. And these devices, these firewalls are extremely expensive and difficult to scale. So now, if in most data centers, the majority of traffic is east-west. So now if you're embarking on this east-west journey to figure out how do I secure it, now you've got to send even more traffic than ever before to these firewall appliances, right? So you got to make sure you scale it to the bandwidth needs of your entire fabric for east-west, which, if it can be hundreds of gigs many of the time. So it's very difficult to scale. And if you don't scale it properly, then, you're sending all your traffic to a centralized choke point, right? And these are oftentimes latency and performance sensitive applications and workloads. It's very challenging. You don't want to be the bottleneck there. This type of architecture is also limited to a single function, right? So in here, we're showing firewall as a use case. So it's limited to security. And let's say you go through all this work to implement this type of solution, you're really limited to just what we call macro level segmentation, right? So you can do security between VLANs, between subnets, between zones, but these firewalls, they don't see any of the traffic happening at layer 2 or that, that switched traffic, that intra VLAN type traffic happening down on the top of rack. That traffic will never make it to the firewall. And so it has no ability to kind of grow into any micro segmentation solution. Now, with a distributed services architecture, and this is one with the CX10,000, we're moving those security and services closer to the workload, right? So here in orange are the CX10,000s, and these are typically your first physical switch in the rack in the data center, right? Every rack has a networking device, sometimes two. Now, we get some great benefits by doing this. One is now traffic can just traverse its native path. So if you, again, have that same use case of workload in rack A wants to talk to workload in rack B, and you want stateful security in there, you don't have to redirect that traffic to the appliance anymore. Now you can provide that security in line because that traffic is going to flow through a top of rack switch. We also get the added benefit as depicted on C. I mean, now traffic, if it's switched on the same switch, that never has to leave that rack, right? So we can provide stateful security even within that same rack as well. And we're doing this at wire speed. So each CX10,000 has 800 gigs of capability. Many times you have a pair of switches, right, in every rack for redundancy reasons. That means you have 1.6 terabits per second per rack of available services like firewall. Think about what it might cost you to get that level of performance in a centralized firewall. It would be extremely expensive. We also can do not only the macro segmentation that traditional firewalls can do, but we also can get down to the micro segmentation level, meaning we can do stateful security even within the same VLAN, right? These switches, they're seeing all the east-west traffic routed and switched, right? So for us, in the same deployment model with the same policy model, operationally, it's the same for us to just put policy, whether it's between layer 3 boundaries or within the same subnet, right? So giving you a lot of flexibility in how you deploy your policy within the environment. And from a deployment standpoint, we'll talk about this in a second. It's really simple to deploy because we're not a net new device in the data center, right? We're first and foremost a switch, and oftentimes customers day one are deploying us as such as a switch and then enabling the services like firewalling in the future when they're ready or the business requires it. And a scaling standpoint, I know many data centers don't necessarily growing at rapid speeds, right? But if you think about it, over the life cycle of these switches, right, 5, 7+ years, your data center may or may not be growing over that time, right? And for us, scaling really is a non-factor because if your data center does grow, you're basically paying as you go as your data center grows. And what I mean by that is if your data center grows, you're going to add a rack of compute or appliances or whatever it may be. That rack is going to have a networking device in it, right? And if it's a CX10,000, every time you add that 10K, you're effectively adding 800 gigs to your overall services capacity of your entire network, right? So it's very sort of linearly grows as your data center grows. And all of this is managed centrally by something called Pensando Policy and Services Manager. So from a central place, think of that as where you're logging in, you're configuring your firewall policy, and that gets pushed out to all the Pensando DPUs living across the environment. And logically, just think of it as a firewall policy blanketing or protecting the entire workloads, right? Really just sitting on top of the workloads, providing that stateful policy as traffic flows through the 10Ks. Now, I said there's two kind of architectures we compare to. The second one is, these agent-based approaches. These are scale-out architectures based on software. So think of Illumio, Guardicore, or even I would classify VMware's NSX as kind of in this category, right? So these are services running in software directly on the host. So, they are distributed architectures just like the CX10,000. So they're putting those security really close to the workloads, just on the other end of the wire. The challenges, though, that we see customers running into with this approach is that first and foremost, it's very difficult and expensive to deploy those agents everywhere in the environment. These are agents running directly on the workload. So putting costs aside for a second, there's usually technical or political reasons why you can't deploy them everywhere. On the technical side, maybe it's a legacy environment or proprietary OSs or management network. On the political side, maybe it's, application team doesn't want an agent bogging down the application from a performance standpoint. Maybe the app team has compliancy reasons why they can't put extra visibility or security on there. Um, there will be ways that you'll find that you cannot blanket the entire data center with one single agent-based solution. And so it becomes a very fragmented approach to solving east-west security. And I already alluded to it before, but because these softwares are running, or these agents are running in software, they are taking up CPU cycles from the actual host, right? And those CPUs are meant for the actual business critical applications, the revenue generating applications. We don't really want those CPU cycles going to dedicated running the services, right? We want them to running those applications that we care about. And that overhead problem will get worse over time as server speeds increase beyond, 1 gig, 10 gig to 25 gig and beyond. And as you start to enable, multiple services, maybe you start with firewall, you enable telemetry, then encryption, those services each are taking chunks out of the CPU, right? Which bogs down the application and really equates the cost of the overall infrastructure because you got to build more infrastructure just to run those services on the server side. And the last, but probably not least, the most common thing that customers we hear are the agent fatigue, right? Every solution seems to have their own agent. And operationally, teams are sort of sick and tired of having to manage and install all these agents over the infrastructure and have that sort of data and solution be tied to that one solution, right? And so they have kind of agent fatigue, if you will. So the way to think of the CX10,000 in this approach is we're putting all those services and running them in hardware on the top of rack. So this allows us to deploy a sort of an agentless based approach, right? So we have a lot more flexibility to what we can secure downstream from the CX10,000 without any impact to CPU resources downstream. So we also get the added benefit now that now the security stack is one step removed from the thing we're trying to protect. So saying that another way, the workloads are no longer being secured by something that lives in the same x86 space as itself, right? So what prevents a hacker from, if something does compromise that workload, what prevents it from root access or disabling that security stack living on the host? Now we're reducing that attack surface because it's one step removed from the thing we're trying to protect. Now, from a migration standpoint, we from a networking, we're using standards-based networking, as I said before, right? So we can fit into existing networks. It doesn't have to be an Aruba spine or core switch. Obviously, we'd love it to be an Aruba switch, but from an interoperability standpoint, there's no requirements upstream of what that device needs to be. It's just standards-based networking. And so day one, we're fitting into a lot of network lifecycle conversations, right? You have existing top rack switches that are aging or you need infrastructure or need to be replaced, maybe end of sale or support, or maybe data centers growing. And we can fit into many different network topologies, right? Whether it's full VXLAN EVPN, layer 3 based data centers, or even layer 2 based data centers, if you still have that, we can fit into those by having the CX10,000 still provide those services in these different architectures. And so day one, when you deploy it this way, look and feel wise, it's just like any other Aruba switch, right? So you can, if you're familiar with Aruba, you'll be right at home with deploying in 10K from a operational standpoint. And if you're new to Aruba, this might be a great opportunity for you to get comfortable in inserting the network side of things on the 10K into the environment before sort of taking on the stateful services side of the switch. From there, typically customers will start to introduce macro level segmentation. So that security of workloads for east-west between workloads that are in different VLANs, much like traditional firewalls might do. So this policy model should be very familiar to a lot of those that have worked with firewalls or the like. And so if you already are doing some level of east-west security with the firewall, this could be as simple as migrating those firewall rules down to the CX10,000. Or this could be a great opportunity for you if you don't know what your security policy needs to be, which is a very common thing to happen. Then this might be where you just maybe enable an IP any rule, for example, on our firewall. So, we're not dropping things from policy, but that IP any rule will generate full stateful logs of all the east-west traffic occurring in the environment, thus giving you the visibility of what traffic and flows are happening within the environment, right? And that visibility is sort of the first step to getting to what your firewall policy needs to be. And then from there, and many organizations have the end goal of getting to microsegmentation, right? They really want the ability to have security between every workload, even if those workloads are in the same subnet or VLAN. So that's typically building off of that macro segmentation policy. Our solution provides both, so allows you a path to grow into that level of security, which microsegmentation really aligns with zero trust. Like if your organization has a zero trust mindset or strategy, zero trust is not a product you buy, but this aligns to really removing implicit trust everywhere in the environment we can, because if you're not locking down, the IP port protocol of communication, even in the same VLAN, then there is some implicit trust there, right? We can help eliminate a lot of those barriers. Now, when we say microsegmentation, we also can do intra-host microsegmentation, meaning we can provide security between workloads, even living in the same host. So in the case, let's give an example of VMware, right? If you have a VMware environment and you're running distributed, the virtual switching on the hosts of the ESX environment, if you have two VMs in the same VLAN, they can communicate without ever getting to the physical network, right? If you want to get to that level of security to provide security even in that scenario, then we have a solution for that. It's really leveraging long-standing technology called private VLANs, which really just force the traffic to come up to the top of rack switch. So by deploying private VLANs down in VMware, two VMs in the same workload, same VLAN can no longer communicate, and that pops it up to the switch. That's the traffic path here in orange in the picture. And that allows us to provide full stateful security, right? So in this model, now we really truly are having stateful security for every workload, even intra-host type situations. When we can do this level of security with both VMware and Hyper-V, or really anything that supports private VLANs or something similar to force the traffic up to the top of rack switch. And granted, if you look at the overall data center architecture, probably a very small percentage of your workloads are doing this type of communication within the host. In the broader scheme, you're going to majority of the traffic is already hitting the top of rack switch, which we're doing natively to provide security. Now, another aspect of security is, encryption and data privacy. For us, we have several different use cases for encryption, IPsec encryption to be exact. The services I was talking about before around firewalling are typically, for CX10K sitting on that top of rack for that east-west security. IPsec is usually deployed in what we call border leaf or perimeter type scenarios, right? You have an edge switch that communicates to other environments that you need to provide encryption across, and maybe other encryption and technologies are not sufficient, like MACsec. Maybe you don't have the right infrastructure in between. Maybe it's internet or transport that you don't own. And so we need to use IPsec for that flexibility of transport. The challenge, though, is that IPsec devices are very expensive, especially if you have a high bandwidth or throughput requirement. So with CX10,000, leveraging that DPU and our encryption module on the DPU, we're able to get 200 gigabits of full duplex IPsec encryption. So 200 gig encrypt, 200 gig decrypt per CX10,000. And use cases might be, terminating IPsec across DCI. Maybe you have multiple data centers, call it private cloud, if you will. We can do IPsec to public cloud. IaaS providers, you're often doing IPsec fully to those clouds, We're using standards-based IPsec, so we can terminate those too at high rate, as well as even colo. Sometimes you have connection to colo-location providers that you might need encryption to because of the transport. We can provide that as well with high rate of speed, right? 200 gigs per CX10,000. The last thing I want to talk about is a use cases around visibility. Some might argue that visibility is the most important thing when it comes to the CX10,000 or just security in general, right? Because you can't really secure what you can't see. And for us, we're really taking an ecosystem approach to this, meaning we're leveraging standards-based telemetry that the CX10,000 system generates. So that could be as simple as our firewall logs. Our firewall logs are using standard syslog, which can be then in turn exported to your existing, SIM tools or syslog collectors, Splunk, etc., as well as full flow telemetry. So we export using a standard IP fix format, which is very similar to NetFlow, giving you not only full flow visibility, but including metrics and information into that flow packets like TCP retransmits and packet loss to give you more detailed information about what is the flows experiencing across the data center. One of the things that makes this unique is not only are we leveraging all this open standards telemetry, but we're taking advantage of the DPU to generate this. So this telemetry does not impact the performance of the switch, which is meant for routing and switching. There's zero impact to routing and switching from a telemetry standpoint, as well as we're taking the power of the DPU. We can actually generate this telemetry, what we call unsampled. So we can take it as snapshots of this data at as little interval as you want, down to basically no interval, if that's what you're looking for, per packet telemetry, which is extremely powerful. That wasn't really capable before of traditional switches, whereas other devices like switches or firewall that might have generated NetFlow or IPFix are oftentimes what we call samples. So they might give you information in 1 in 10,000 packets, which really doesn't show you the full picture of things happening for east-west. Now, we're going beyond just exporting to other tools. We really are building towards a model where we can get sort of full feedback loops for day 2 operations within the data center. For the first time ever, the device providing network service, the CX10,000, is also now providing the source of truth for telemetry, as well as it can be the enforcement point for things like firewall and security. And so imagine creating a full feedback loop of those things working in harmony, where we're leveraging external tools that have different specialties, whether it's network performance, whether it's security, compliance, etc., letting those tools do their magic, leverage their own best-in-class algorithms and machine learning, and then feed that decision or outcome back to the network to act on it. Now, let me give you a specific example of one that we have working today is with a company called Guardicore. Guardicore is in the middle here in this application dependency mapping section. What Guardicore does is, their core value prop is, first of all, creating a map of how do applications in the data centers communicate east-west. So that what you see here on the right is a map of a certain application and what are all the things, IP protocol that it needs to communicate to function, right? And Guardicore collects all this data from the agents that they deploy on the workloads, with their ultimate goal of getting to the left, which is turning that application map into actual policy, the security policy necessary to lock down that application in a sort of whitelist model, right? Only allowing the minimum needed communication to happen for that workload and then blocking everything else. And that's achieved by using some of their algorithms to translate that into the policy that you see on the left. So typically, Guardicore works by collecting the data from the agents, doing this workflow that you see here, and then enforcing that policy that's created back down on the agents. Now, the challenge that Guardicore has, as well as their customers, is that exactly what I mentioned before about agents. whether it's technical, political, or cost, it's very difficult to install those agents everywhere in the data center. And so it leaves gaps inside the environment of how that security model is deployed. With our integration with Guardicore, we're now leveraging the CX10,000 to feed our telemetry into Guardicore's dashboard. They're still doing the same magic you see here of mapping the application, building out the policy. Now, the difference again is instead of pushing that policy back down to agents, now they can also push that policy back down to the CX10,000, right? So really creating that full feedback loop of having policy be automatically evaluated and created and pushed back down to the network, right? So a really automated day two approach to creating east-west security policy in the data center and achieving all of that without installing agents everywhere in the environment, right? So really saving down on costs and taking advantage of the capabilities of a next generation network to feed into systems like Guardicore. The other thing that I want to mention before we wrap up is, it's as simple as exporting data to dashboards, but now we can give, network and security teams full visibility into all the flows happening east-west in the data center, which I'd be willing to guess that most teams don't have access to that level of visibility of all flows east-west. Sure, you have visibility of the flows north-south, typically getting that data from, a traditional firewall, but east-west has been kind of a black box or a gray area, if you will. By leveraging the 10K, and here's a screenshot of a quick dashboard we built in Elastic, leveraging an elk stack. The right picture is the most interesting because that's our lab, and that shows you every single flow and communication on IP port and protocol that's happening within that environment, right? Which is extremely powerful to have access to. So that's our approach on the telemetry and ecosystem side, right? Really, our goal is to fit into your existing investments that you've already made, right? Really by feeding those tools better data and better insight or better telemetry, so they can in turn have better insights from their algorithms. Doing all this without any agents in the environment, without impacting CPU resources or impacting network performance. Really, that's the power of building this new generation of networks. I lied. I said I had one slide left. The last slide actually is, now think about as you're building, your next data center, as you're refreshing your data center network. I think it's very easy to just focus in on, okay, what is the cost of my network going to be? When you look at the big picture of what the CX10,000 is doing from a network side, as well as security, visibility, I challenge you to think about what would it cost to implement those solutions to have those same outcomes when you're buying or purchasing disparate solutions like the dedicated appliances I mentioned before, like the agent-based approaches. Those solutions still have a network infrastructure they rely on, right? So you're still buying switches when you have those security solutions. With the CX10,000, there's significant TCO advantages by collapsing all those services down on the one platform. And you can see here, we're well within, 10, 20% ballpark of traditional quote unquote switches, which is a fairly small premium to pay when you get all this east-west security and telemetry services along with it. And our licensing is perpetual, right? So, distributed firewall, DDoS, and telemetry, that license is yours forever for the life cycle of the switch. And so there's not a ticking clock on you to, hurry up and deploy these services day one. Day one, you can deploy it like a network and then start to enable these functions, when you're ready. So I hope that was an interesting overview of what we're doing. We're building kind of this new generation of data center networks and leveraging the power of the Pensando DPUs together with Aruba CX. I'd be happy to take any questions or maybe schedule a follow-up. We can do a deeper dive onto the solution and how it might fit specifically in your environment.
Well, thank you so much, Stephen. That was a lot of value-added information. You have done a few of these virtual events for us, and you always do such a great job, such a thorough, comprehensive job, and we appreciate you. So as you mentioned earlier, and I can attest to this, if you would like to have Stephen and his team, which is Scott Chung, come out and visit, and provide an on-site presentation for your team. He's always open. He's always a team player, and he's always ready to help us with that. Our goal today was to entice you with enough information regarding all of the security protocol built into the data center switching platform, as well as the unique feature sets that we have in the CX10K. And hopefully we've done that. Hopefully we can set up our next steps in those conversations regarding the customization for your unique environment. And just as I mentioned earlier today, we are going to have a recording of this. I'm going to pull some snippets and do some highlights, and just put together like a little narrative, so that you can share these with your teams. Again, as I mentioned, I don't know that this was the best week, and I feel so bad. We had a lot of individuals joining our or registering for this event, but many are on vacation. So we will definitely have to get this to them. We will also provide a feedback survey, and we thank you for your valuable time today. If there's any additional information that you would like, you can always reach out to your local territory manager and or your SE, and we can move forward with next steps. Thank you and have a wonderful week. And Stephen, again, thank you for always being such a great sport, a team player, and helping us out.
Yep, of course.
Thank you. Bye-bye.
Thanks, everyone.